Hello everyone. This video is about the simulation of buck converter. Open MATLAB, type Simulink and press enter button. Create a new model. Now we can construct the buck converter. We can take the parameters of the buck converter as given in the table. The circuit of the buck converter is shown here. We are going to construct the buck converter for the given parameters. To construct the buck converter, we need a voltage source, DC voltage source. Choose the DC voltage source from the specialized power systems and source tool. We need the voltage source magnitude to be 12. Let us rename the voltage source as Vs. Then we need a MOSFET switch. An inductor which can be obtained from RLC series branch. Then right click on the series branch and Control R to rotate it. We need 2 more RLC series branches. Then click on the RLC series branch and make it as L. And let us rename the RLC series branch as L. Then click on the another RLC branch and make it a C and rename the branch as C. Then click on the third one and make it as R and rename the branch as R. Then we need a diode. Control R to rotate the diode as per the given circuit. Then let us connect to all the components. To form the buck converter. Then we need a pulse generator, PWM signal, for which we need to have a pulse generator to give pulses to the MOSFET switch. The pulse width of the pulse generator will be 40%, as we have taken the duty ratio as 0.4, and the time period has need to be changed to 1 by 25 kilohertz. To see the waveforms, to see the output voltage waveform, we need to have a voltage measurement block. Then we will measure the currents such as switch current, inductor current, and the diode current and the capacitor current. We will measure three currents: switch current, which is also the source current, then inductor current, and then capacitor current, for which we need three current measurement blocks. And these three current measurement blocks should be connected in series with all the three elements such as a switch, inductor, and capacitor to see their current waveforms. So the first current measurement block is connected in series with the switch. Then the second one is connected in series with the inductor. Then the third one is connected in series with the capacitor. To see the waveforms, we need scope, and we need to see all the four waveforms, three currents and one voltage waveform. So click on the scope and click on the view tab, and then configuration properties. Make the number of input ports to be 4, so that we will have 4 input terminals for the scope. We can connect all the measurement blocks to the 4 input terminals of the scope. So we are connecting the current measurement blocks to the scope, and then voltage measurement block to the scope. Then in order to run the circuit, we need a power GUA block. Before running the circuit, we have to change the default values of L, C, and R. L value was taken as 145 microhenry as given in the table, and then C value is taken as 200 microfarad. Then load resistance value is taken as 14 ohms. Now we can run the model. So we have obtained all the 4 waveforms. In order to see the waveforms in different axes, we need to choose the number of axes to be 4. Now let us change the time of run period, and again we will run this model. After running the model, we are able to see the four waveforms.